So now we have talked about how we are going to name, at least initially, our alkenes and alkynes. But now we have something additional that we have to think about. And these are called cis-trans isomers. So looking back at our alkanes, just for comparison before we introduce what these are, let's look at our alkanes. So single bonds can rotate. So these two molecules are the same molecule. So it's just a conformer where you're rotating one of those bonds. So those two molecules are conformers of each other because we're just rotating a bond that is allowed to rotate. Oops, sorry. So these are the same molecule. That doesn't say molecule. There we go. E. Oh my goodness. Cannot spell today, guys. However, when you're taking single bonds and you add an additional bond, double bonds actually cannot rotate, at least freely. An actual chemical reaction must occur for double bonds to rotate. So these two molecules are not the same molecule. These are different molecules. So substituent locations are fixed relative to the double bond. So you can see how on the first one, the two substituents, they're on opposite sides of each other. And on this one, they're on the same side as each other. So they're both named 2-butene, as we talked about in the previous video, but they are cis-trans isomers of each other. So a cis isomer, let's pick a color. Let's do blue, why not? A cis isomer is when the two largest groups are on the same side of the double bond. Cis is same side. And trans is when the two largest groups are on the opposite side of the double bond. So a cis isomer, you can see here, this side, these two substituents are on the same side. So instead of just calling this molecule 2-butene, we would have to call it cis-2-butene to show the orientation of those two bonds. And then on this one, we have three groups, so we have to figure out how to associate which one's which. So in this case, we're going to have the two largest ones on the same side. If you have carbon and carbon, then you're going to say the largest one is based off of which one is bigger, right? So this ethyl group here is bigger than the methyl group, so that's the biggest one on that side. And then the same goes for the trans. Now they're on opposite sides of one another. So when you're trying to look at this, something that I like to do is put a dotted line down the center of the double bond so that it's perpendicular to where your bond is. So for example, I'll draw a dotted line right here. That's not very dotted, but you get what I mean. And I compare one side to the same side. So I'm going to compare these two, this one and this one are the two I'm comparing, not on the opposite sides of those of that dotted line. We'll do some examples of this on the next slide. So to name cis and trans isomers, alkene isomers, we're going to have to put the prefix cis or trans in front of the alkene name. So let's look at this first example here. We have 1, 2 in terms of our number of carbons. So we're going to have F, ETH, and then ENE. So we have an ethene. In this case, we don't, because it's a symmetric molecule and there's nowhere else for the alkene to go, we don't necessarily have to say where the alkene is. But we do have two substituents. So we have this guy here, this guy here. So we have dibromo, one at the 1 and 2 position. In front of all of this, so this is what we've learned before. Oh, I didn't want to do that. This is what the naming that we've learned before. In front of that, we have to say if it is cis or trans to show what that relative configuration is. So I'm going to draw, let's do this first. I'm going to draw my dotted line perpendicular to my alkene and compare one side to the other. So I'm going to draw in my hydrogens for this example, but looking at, goodness, I don't know how I keep doing that, guys. Okay, looking at this side of the dotted line, I'm going to pick which one is bigger. If you're not sure, base it off of molecular weight or which one has a bigger atomic number. So bromine is definitely bigger than hydrogen. Other side, now we're looking at the opposite side of the dotted line. Then again, we have bromine is bigger. So we have on the same side, so now we're looking in at opposite sides of the dotted line. They're both on top, so therefore those bromines are on the same side. So this would be called cis. So we write cis dash 2 1 2 cis 1 2 dibromoethane. Ethene. I'm sorry. We'll get there. We'll get there. So we don't actually need that dash unless we have a number there. Okay, so that's our first one. That was a mouthful, huh? Okay, let's go down below that and try this one now. Okay, so we have 3 carbons in this one. We're going to start where our alkene is, 1, 2, 3. So we have prop. We have an alkene, E-N-E. We have to say that the alkene's at number 1, because now we do have a choice as to where that alkene will go. 1 propene. Then we have a substituent here. So let's label that substituent on here. So at the 1 position, we have a chloro. Okay, and then lastly, we have to decide if it is cis or trans. So if we draw our dotted line, chlorine is bigger than hydrogen on that side. Methyl is bigger than hydrogen on that side. Those two are on the same side, so this one's also cis. We're going to draw a line right here just so we're clear what's what. Okay, let's do another one. 1, 2. We don't really need to say where this alkene is because we only have one option as to where it can go. But we have F is our main number of carbons, ETH. ENE for our alkene, ENE. We don't need to say where that one is again because it has only one place to go. And then we have dibromo. This dibromo is at the 1 and the 2 position. And then lastly, we need to say if it's cis or trans. So we draw our dotted line through this perpendicular to this double bond. We have bromine are the biggest ones. Now you can see that if you hold that dotted line flat, they're on opposite sides of each other. So we have trans 1, 2 dibromoethene. Okay, let's try one last one. 1, 2, 3, 4, 5, 6. We have no substituents on that one, so this is nice. So we have hex, hexene, because we have that double bond. The double bond starts at the 2 position. Okay, and then we need to say what orientation it is. So if we draw our dotted line through the middle, we can see we have a carbon down here, carbon up here. Those are on opposite sides of each other. So this is trans. Trans 2-hexene. There you go. Okay, and then lastly on this slide, we have a danger in that not all alkenes have cis or trans isomers. So if you go back to the previous lecture, you'll notice that none of those have cis or trans isomers. And the reason is because you can, if one carbon atom is attached to two identical groups, then you can't have cis-trans isomers. So for example, in the second molecule here, if I draw my dotted line, there's no winner between these two bromines. They're the same thing. So I can't say what they are. This first one's a little tricky because you're like, but what are the identical groups? Bromine and methyl are different. But we have two hydrogens here, right? Those are two identical groups. So this hydrogen and this hydrogen, you cannot differentiate between. Therefore, there are no cis-trans isomers in this molecule. Next slide is some practice. Try it out on your own, and I'll meet you guys there for the answers.